Hello everybody, welcome to something a little bit different. This is called A Slower Speed of Light. It comes out of the MIT Game Labs, and what it is, I'll just let it give its little explanation. Once upon a time in a quiet village there was a little child. Sadly, the little child fell into death's icy grip far too soon. The little child's spirit began to journey to become one with light. But the speed of light was too fast for the small child and clumsy little spirit. Luckily, the spirit world is full of magical orbs that slow down light. Collect orbs to slow down light to walking speed so you can finally move on. How many orbs you get, this is how your speed compares with light. As light gets slower, you will start to see beyond what humans can typically see. And look at options, whatever. But yeah, this basically takes quantum mechanics and brings it into a setting where you actually get to experience. As you can see, we're seeing things pretty normally. We're moving at normal human walking speed. And now we're moving a little bit faster. I can't really notice too much yet. But if we move a little faster, you can see things start to get a little bit more vibrant. And as we go backwards, they get a little more desaturated. They turn more purple the faster we go, because we're going into... If they turn more purple, but we're going towards the ultraviolet. Because what it's doing is, if you look down at it, what happens is the faster we go, the more compressed light becomes in front of us. So we start to see farther and farther into the infrared. Which is really cool. But you don't really start to see the effects until we start to pick up more orbs. You can see we're moving faster, faster. Things are shifting into the spectrum. We're going 27, 28, about 30% the speed of light. Now if we go backwards, see how different the color shifts? Because we'll be looking in the ultraviolet. Right now we're looking into the infrared. So we can see infrared light in front of us. The best way to do this is to go sideways. You can see infrared over on the right side, or over on the left side. I don't know. I can't. It's little people. But anyway, if we go in this direction, you can see infrared on this side and ultraviolet on this side, which is really cool. You get the Doppler shift. So let's just pick up now where we're going. Whoop, excuse me. So we just need to pick up the last couple more orbs here. You see, once we get about 50, things really start to get interesting. See, I'm picking all the ones that I got. Whoa. Okay. Pick up all the ones that I have to stop and turn and move with, so that we can hit the long runways and not have to slow down. But that's when things really start to get interesting. Backwards, let's see. Wow, yeah. UV looks really cool. And infrared looks really interesting as well. As you can see, there's a little bit of distortion. That's caused by the Doppler shift, the compression of the light waves. This is really, yeah, now we're starting to see, we're going at almost 60% the speed of light. We're seeing really far into the infrared now. Things are really starting to get distorted when we start to pick up speed. As you can see, we're starting to see all of the, and then when we stop, everything goes back to normal. Yeah, things are really starting, now that we're going almost 70% the speed of light, things really start to distort. Now watch as we zoom away. You can only see the infrared. Only things that are giving off infrared can we see. And now when we go this way, not infrared, that was ultraviolet. I get my sides of the spectrum screwed up. But yeah. But now that we've got a pronounced difference, let's go sideways. You can see the distortion. You can see the spectrum lines. So the infrared is being compressed and the ultraviolet is being drawn out. Yeah, we're going almost like 80% now. 87. Yeah, look at that. That massive amount of distortion. Now there's the UV. Here's the infrared. Yeah, the orbs get kind of hard to, the amount of, you know, with just the momentum you have to deal with. Whoa. Even the art style's kind of not bad either. I mean, it looks interesting. Just kind of, I mean, this is a simple just object gathering game. But what sets it, what makes it interesting is this light speed mechanic. Almost finished. 96, 87. Okay. 99. We got one left. But before we gather that, I'm gonna play around at 99. As you can see, things get really shifted into the infrared. If we turn it around, watch. Massive distortion. Yeah. And then it happens again as we go forward. Things get really drawn out because we're going faster. And then when we stop, everything goes back to the way it normally is, and then we go that way. Things get really compressed because they're having to travel farther to get to us. It's the Doppler effect. It's like when a car, it's like, you've experienced it, it's when sound. And now, speed of light, watch. Wow. Yeah. So what I'm going to do is I'm going to go all the way up to the, I just want to blaze straight through. Now this is what happens when we go backwards. You see, it looks like we're going slower, but that's because light takes longer to get to us. And the same way with it takes it's really this amount of just crazy distortion. And we gotta hit that. Yeah, and now the game is over. Pretty fun game, interesting. The end. Yeah, what happened? Make everything as simple as possible, but no similar. In the slower speed of light, the speed of light slows down with every orbit you pick up. It's impossible for it to reach the speed of light, but certain relativistic effects become more visible as you get very close. Because, like I was saying, light waves behave like a wave, and the different wavelengths appear in different colors. As you and other objects move around, the wavelengths of light change, appearing redder or bluer to your eyes. And visible infrared, visible ultraviolet. Some light becomes infrared or ultraviolet, which your eyes cannot usually see, and other visible light sources of light become visible. Moving left, the objects on the left are brighter than the objects on the right. Light also behaves like a stream of particles called photons. When you run towards the stream of photons, more photons hit you and the object becomes brighter, which is also known as relativistic aberration. Light always moves at the same speed, so if the speed of light is constant, then the distance and time in the world around you have to warp. Your time is different from the time in the world, and your distances are different, and differences in the distances in the world. Lorentz transformation. You have to be much closer to the speed of light to notice the more dramatic effects of Lorentz transformation. Compared to the Doppler and searchlight effects at the end of the game, the Doppler and searchlight effects are removed to make Lorentz transformation easier for you to see. Normally, light is extremely fast, but it still takes time for photons to reach our eyes. When you look at anything, you are actually observing incoming light from some time in the past. The further you look into space, the further you look into history. This is easily noticeable when you look at objects moving relative to yourself. Objects normally beyond your field of view can become visible when you move near the speed of light, as you see them as they were in the past. And these are all the scientists and physicists and people that worked on this. So yes, this is a slower speed of light. Quite a fun little game. Interesting. It's not so much a game as it is an interesting little experiment.